This is a short video just explaining what I didn't quite have time for in class about how to graph inequalities, linear inequalities. So let's just get straight to it. You can see the two that we have up here. So y is greater than x plus 4, and also y is less than or equal to negative 0.5x plus 1. So we'll start with the first one. So our steps for graphing linear inequalities like this. Step one is, need a little more space. Step one is graph it as an equation. So take your inequality, imagine that it was just an equation. Let's write that out here. Y equals x plus 4. So graph that line first. Graph y equals x plus 4. And x plus 4, so y-intercept is here. B value is 4. The slope is slope of 1. So that's going to be perfectly 45-degree angle line like that. So let's draw that on our graph. Going to go up here and down like this. Okay, so there is the line y equals 4. That's a good first step. We are not done though. Step 2 is shade one side. We have to sort of color in one side of this. The graph is y is greater than x plus 4. So that means that the solution to this, the list of points that will work with that, it's not just the points on a line, it will be a whole big area, either all of this or it will be all of this. And off to, infinity in every direction here. So which one is it? Is it going to be above the line or is it going to be below the line? Well, first we can say here, this is y is greater than x plus 4. So let's imagine that we have a point, let's say this point right here, where x is equal to negative 2. So y can be x plus 4, negative 2 plus 4. So 2, but then greater. So for this point here, our inequality tells us y must be greater than 2. So what does that look like? That looks like all of these points. So when x is equal to 2, y can be anything above that point. So all of those. So that's one way of thinking about it. So that means we're shading everything above. The other way that we can think about this is you can just test a point, any point you want. Usually the easiest one to test is going to be this right here, the origin, 0, 0. So let's take our inequality, y is greater than x plus 4, substitute in our point, 0 greater than 0 plus 4, and then 0 is greater than 4. Okay, we have a statement here and we will evaluate that statement. Is that a true statement or is that a false statement? If it's a true statement, then that means that we are going to shade in the area that includes this point, because that point is a solution to the inequality. So that point is part of the solution space. It's included in the inequality. If this is a false statement, then this means that this point is not included and we should be shading everything on the other side, just not the side with that point that we tested. Well, 0 is greater than 4. No, it's not. So the point 0, 0 is not in our inequality, and all of this is. I'm going to shade it this way which will just sort of indicate which side, and then we kind of understand that it goes off into infinity over in this way and up this way. Okay, so we'll draw it like this. So this is the first one. Sorry, not totally done yet. Last thing, we've shaded the correct side here. Now we need to check if this is a dashed, if this should be a dashed line. Dashed line. So a straight line would be this. A dashed line would be like this. Sorry, not straight line, a solid line. Solid line means that the points on the line itself are included in the inequality. A dashed line means points up to the line are included, but points that are perfectly on the line are not included. So in this case, we have in our inequality, so once again, it's y is greater than x plus 4. So here must be greater, strictly greater than. It cannot be equal, it must be greater. If we come back and look at this point that we had here, where x is equal to -2, we said that, okay, y, we figured this out, y must be greater than 2. Y cannot be equal to 2. That is not a solution to the inequality. Y must be greater than 2. So thinking about that, we can say, okay, the points here, -2, 2, it's not actually in the inequality. So we will represent that with our dashed line. The other way of thinking about this is just very simply, this is a greater than symbol. It's not a greater than or equal symbol. If it's a or equals, then it'll be a solid line. If it's strictly greater than, then it's a dashed line. So we'll draw this in here. Might look like I'm not actually drawing anything. I'm drawing the dashes, and we'll see them as soon as I erase the solid line here. All right, there's our dashed line. Not super pretty there, but it works. Okay, so we imagined that it was an equation and we drew that line. And then second, we shaded one side of it by testing a point to figure out which side to shade. And then third, we checked if it's a dashed line just by looking at the sign. Here it was a greater than, strictly greater than. So that tells us that it's a dashed line, wasn't a greater than or equal. All right, well, we have to do this whole thing again for the next one. So let's do that. So here we have y is less than or equal to -0.5x. We can do this a little faster. So here's our y-intercept at 1, and then our line is going to actually go over this. I'll have to move this out of the way. It is going to go like this roughly. Let's get the exact values done. Like this. So here is our line. This is, once again, our line. Y equals -0.5x plus 1. So next thing, shade one side. Should we be shading above or below? So we can think just less than or equal. So that means the y value should be below that line. So we're going to shade everything below. The other way we can think of this is, once again, testing a point. If we take our point here, the origin 0, 0, put that into our equation. I'll write that over here. Y is less than, sorry, not our equation, our inequality. y is less than or equal to negative 0.5 x plus 1, so 0 greater than, less than or equal to negative 0.50 plus 1, so 0 less than or equal to 1. This statement here, is this a true statement or a false statement? Well, 0 is less than or equal to 1. That is a true statement. So in this case, our point here at the origin is included. We'll be shading everything below the line. Let me just erase the origin here. So we're shading like this. All right, and our third step here, check if this should be a dashed line, while our sign is a less than or equal. So the points on the line itself are included. Those are part of the inequality. That's okay to include them. So solid line is what we want. So we're done, kind of. We have graphed the two. We have done that successfully. We have our accurate graph here. The last thing I'm going to ask us to do, or that we will do, or I will do here, is imagine if this were actually a system of inequalities. So not just the red one and the blue one independently, but what if we take the two of them and we throw them together? And we want to make the graph showing the solution to both of them at the same time, not just this, not the solution space to each of them independently, but what area, what part of our graph includes all of them. So basically we have four choices. It could be one, it could be this whole area like this. It could be two, it could be this whole area. It could be three, it could be this whole area, or it could be four, it could be this whole area. All right, well, let's consider each of these one by one. So area one up here. So the red shaded area does go over kind of off to infinity in this direction, but the blue one doesn't. Blue one must be below over here. So number one includes the red area. It does not include the blue area. So it's not number one. Number two does not include the red area or the blue area. So 2 is not a solution to any of the inequalities, even independently. Not number 2. Region number 3 down here, well, it is a solution. Let's get rid of this bit here. It is a solution to the blue one, but it is not a solution to the red one. So that one also is not going to work because the red one has to be over on this side, and we can see where this is going. So the solution to this system of inequalities is actually this whole space here. Let's try that again. So this whole space like this, nice big solution space. That is the solution to our system of inequalities. If we get rid of these two, then we can see it like this. We have to be below the blue line and above the red line at the same time. So 4 is the solution space. It's touches, goes up to and includes the blue line. It touches the blue line, and then it goes up to, but does not actually touch, just goes infinitely close to the red line, the red dashed line here. So that's how to graph an inequality separate independently or just on their own, and then how we can combine multiple inequalities to make a solution area on our graph that represents the solution area to both inequalities at the same time, not just the solution area to one of them. So the preview question, we're going to do a bunch of stuff with this next week, and the preview question for that's going to be due on Sunday uses this. So if perhaps if you've never seen this kind of graphing stuff before with inequalities, this is enough for you to be able to try the preview questions. If not, take your best shot at it. If I'm not able to figure it out, that's all right. We will look a bit more at this in our next week when we start talking about linear programming. I hope this was helpful.